Example 1, we have the function fx equals to 3 minus ln bracket 2 minus x, and according to step 1, these examples here already fulfill the form that we would like to have for the log function, where first of all, the base number of the log here is the case that we have it greater than 1, where this is log to the base e is greater than 1. We have the bracket terms here come with linear expression. The rest of the parts doesn't consist of x. And if you want to compare in details between the general case and also the examples here, we find out that the capital A here corresponding to the coefficient of the log is -1. The base number of the log is base e. The m is the coefficient of x, which is -1. C is the constant in here, in the brackets here, and k is the constant that we have it outside of the log. Next, once the type is already determined, next we go for the shape of the graph. Let's see how we determine the shape of the graph here. Again, we observe two things here. First, we observe the coefficient of the x. We observe the coefficient of the log. Again, I want to emphasize, must be in the situations that we have the base number of the log is greater than 1. Then only we proceed to determine the shape of the graph. The basic shape that we should bear in our mind is the case like the following, where in this case here we have our coefficient of x is a positive value, and also the coefficient of the log is positive. So this is the basic shape that we have, and according to what we need in these examples here, we have negative on the log, negative on the function, negative on the x coefficients. So what we need to do is that let us slowly transform it. So first of all, let us consider the case that from positive x, the positive coefficient of x, convert into negative coefficient of x. And what we will find out is that from positive x convert into negative x, we will have the graph flip horizontally, and as a result, this is how it looks like. And further, according to the example here, I need to have negative coefficient on log also, so I need to convert into negative coefficient of log. And in this case here, what will happen is that from positive log convert to negative log, I will have the graph flip vertically. And this is the form of, this is the shape of graph that I should have for these examples here. Next, we go to step 3. We would like to determine the special line in this case here, which is the vertical asymptote. So the vertical asymptote, as you can see, is this dotted line here. And the way we get the answer is that we consider the bracket terms there, 2 minus x. We make it equal to 0, and we have the answer x equals to 2. And this will be the corresponding vertical asymptote that we would like to have for answer. And rush up to step 3 here once again. By right at this moment here, we can make use of the special line and also the shape of the graph here to roughly estimate what is the domain and range we have in this case here in general. So when the time we extend this graph here, what we will see is that for domain, we would like to see how far to the left and how far to the right the graph can go. So the graph here we can see it can go in the case of go to the left infinitely, go to the right very close to 2 but never equals to 2, so 2 open. Whereas for range, we can see that it always can extend, it can extend downwards infinitely, extend upward infinitely. So we have the domain and range here, infinity to infinity in general. Okay, next, we would like to go on with the intersections on x and y axis. And what we're going to do here is that we try to do a rough sketch by using our first, the special line, which is the asymptote here, x equals to 2. Then we put in the shape of the graph that we have. So this is what we find out. And from our observations here, we can see that by write this graph here, it should have both x and y intercept. But calculation need to be done to further verify, is this the actual location that we have for the x and y intercept? because who knows, this rough sketching is not so accurate, so we need it to done by calculation. So for y-intercept, we have x equal to 0 substitute into the function, and this gives me the result y equals to 2.31, which is the y-intercept value up to 3 secant figures. And then whereas for x-intercept, we let the function equals 0 and solve by using calculator. I find out that the answer is equals to negative 18.1. Again, correct to 3 secant figures. And with this x and y value, as you can see, we find out that although the rough sketching here tells us that there is y and x intercept, but this is not the actual position. As for y-intercept is positive value, here it shows negative, whereas for x supposed to be negative, it shows positive. So by right, with this information here, now we can go for the graphing, where we get ready our xy intercept and also our important line there. Then now we put in our graph. And there goes the full graph for example 1. And always remember, do label your xy axis, the origin, the name of the graph according to the function name, the xy intercept if they exist, and at last, the vertical asymptote. And this is how we get the answer done for example 1.